So we got 4 vertices, 4 sides, 4 interior angles. Speaking of, do we know anything about those 4 interior angles? What's up? Say it louder.
The measurements sum up to be 360.
Beautiful. I love the way that you said that. The 4 interior angles, their measurements sum up to be 360 degrees. Now, Katie, how do you know that?
Because 2 triangles are in it, so 180 plus 180 equals 360.
Wow, I am extremely impressed. Very good. Yeah, no one's been able to say that thus far. So that's a fact that maybe one of your teachers said, that, yeah, the 4 interior angles of any quadrilateral sum up to be 360 degrees, and that's good, and that's true, but why? And that's what I'm more concerned about, is I don't want you to memorize facts, I want you to be able to explain how and why. And just like Katie said, if you draw in one of the diagonals, you have split this quadrilateral into 2 triangles. We know, and we have already proven in this class, that the 3 interior angles of any Euclidean triangle sum up to be 180 degrees. So those 3 interior angles add up to be 180 degrees. And then we also have this triangle over here. And its 3 interior angles also add up to be 180 degrees. So when you sum it all up, you get 360. So that would be the proof for it. We're going to use a similar method when we get on to pentagons and hexagons and heptagons and so on. And so sweet. How many diagonals does a quadrilateral have? 2. Okay, good. Will we ever come across a quadrilateral with more or less than 2 diagonals? No. So a quadrilateral will always have 2 diagonals. There's not new vocabulary, but in this context, there's 2 words that may be new that I really want to focus on. Identifying opposite sides and angles, so the opposite when you're talking about a quadrilateral, because we talked about in a triangle, we said, okay, well, if you consider this angle, then the opposite side is the one that angle's opening up to, so on and so forth. So it's the same kind of concept, but now we're dealing with quadrilaterals. But the new one is consecutive. Consecutive means, so if I were to ask you to name off the consecutive odd number, starting with 7, you would say 7, and then 9, 11, one after another. Same thing when we're talking about the sides and angles in quadrilaterals. So I'm going to tell you straight out of the gate. This first page, dumb, well not dumb, but boring and mundane and tedious. But please don't zone out, because you need to be able to identify very quickly opposite sides, consecutive sides, and as we learn about these new quadrilaterals, the definitions will use those terms in it. So if you can't simply identify a pair of consecutive sides, then the definition of a kite is going to be pretty difficult for you to understand, because it involves 2 distinct pairs of congruent consecutive sides. So you need to be able to identify that. So let's get after it. So item A, under number 1, asks us to list all pairs of opposite sides. So if I start off with a side, let's say side GM, when I refer to these sides, what geometric object or shape are these sides? That's the question. Is there what? There's segments, right? Line segments. So when you are listing these sides and angles out, please make sure you're using appropriate notation. So if I want to refer to this side GM, it is a segment. So segment GM. And so what side is opposite of GM? Segment EO. I don't really care how you name these sides. If you wanted to call it segment MG and segment OE, that's fine. Right now we're not comparing 2 quadrilaterals. We're not trying to prove quadrilaterals are congruent. So we don't have corresponding parts. So I'm not too concerned with the letter ordering. We're just saying, hey, that segment, and hey, that segment. So don't get too caught up with the letter ordering. So this is one pair of opposite sides. And then the other pair of opposite sides would be segment GE and segment MO. So that wasn't too bad. They're opposite from one another. So segment GE and segment MO. And then part B says list all pairs of consecutive sides. So once again, consecutive is one after another. So if I were to say, okay, here is segment GM. This is one of the sides. So which one is, what side is consecutive with it? Who says GE? Segment GE. Who says segment MO? Who says both? Be correct. Okay? So, side GM and side GE, that would be a pair of consecutive sides. It's right after it if you're going in the clockwise manner. But if you're looking at segment GM, well, you can also consider segment or side MO to be consecutive as well. You would just be going in a counterclockwise manner. Those are two pairs of consecutive sides. There's two more pairs. You got those, and then you have segment GE and segment EO, and you also have segment EO and segment MO. So in red ink, those are your four pairs of consecutive sides. Now, before we go on, I'm not writing these answers underneath here because eventually I'm going to run out of space. I'm going to keep, and it's going to also be like this on the next page, I'm going to keep the diagram in view, and I'm going to start answering all these questions all over the place. So you don't exactly want to copy where I'm putting these answers. Just make sure that you're writing your answers in the appropriate places. Okay. Part C, which I can't see, it says something about, that was weird, sorry, part C that I can't see. It says list all pairs of opposite angles. So underneath that, we need to list off the opposite angles. I'm going to do it in a different color just so I don't mix all this up. So in green ink, if I'm looking at angle G, what angle is opposite of angle G? Angle O. And then the other pair of opposite angles would be angle E and angle M. We are allowed to just use just the single letter naming process, just the vertex. We don't have to say angle EGM is opposite to EOM, not in this case, but understand that that may be a possibility when we're moving on further into this activity. The next item asks for us to list off the consecutive angles, correct? Consecutive angles. So just like the sides, there's four of them, so there's going to be four consecutive angles. So I have angle M and angle O are consecutive. Angle O and angle E are consecutive. Angle E and angle G are consecutive. And then angle G and angle M, those are consecutive. So we have four pairs of consecutive angles. And as we learn about these different quadrilaterals, and we're going to talk about them all. We're going to talk about trapezoids, isosceles trapezoids, rhombi, parallelograms, kites is today, rectangles, squares. We're going to be learning a lot of different properties about. So maybe like if we're talking about a parallelogram, the opposite sides are congruent and parallel. The consecutive sides of a square are congruent or whatever. So we're going to be using this terminology, and so that's what I meant by like you really need to be on top of your game and just be able to identify these very quickly. The last part asks about the diagonals, correct? So it says draw in and name the diagonals. Draw the diagonals and list them. So we agreed that there are two diagonals. So I have here segment ME and then segment GO. Sometimes the diagonals in different quadrilaterals, sometimes they'll intersect to form right angles, so they're perpendicular. Sometimes they'll bisect each other. Sometimes they'll bisect the opposite angles, all kinds of different stuff. So we'll look at those properties as well. Before we move on to the next page, I just want to go over how we name quadrilaterals. Just like when we were naming triangles, we had that little symbol before, so every single time we didn't have to write out triangle, you know, A, X, Y, or whatever. So we just used this symbol and said, okay, triangle A, B, Z, or whatever. Same thing with quadrilaterals. We're not going to write out the entire word quadrilateral, but we're just going to abbreviate it with quad. So you're going to write quad, and then list the four vertices. you need to start with one of the vertices. It does not matter. So let's pick O, and then you either need to go clockwise or counterclockwise, listing off the consecutive vertices. So if I wanted to start at O and name this going clockwise, it would be quadrilateral OMGE. Or you can name it, the other way. It could be quadrilateral OEGM. I'm not too picky about whether you name it clockwise or counterclockwise. I'll know what you're talking about. The one thing I don't want you to do is just to pick random vertices and say, oh, this is quadrilateral OGEM. It just wouldn't make sense. But so this abbreviation is totally okay. Start at one of the vertices, it doesn't matter which one, and then go and list them, the vertices consecutively. Alright, now let's flip on to the next page. On the next page, it introduces the first special quadrilateral we're going to talk about, and it is a kite. The definition at the top of the page says, a kite is a quadrilateral, so know it has 4 sides, 4 vertices. We know that the 4 interior angles add up to be 360 degrees, because it's a quadrilateral. So it's a quadrilateral with exactly 2 distinct pairs of congruent consecutive sides. So there's that word, consecutive. So if you don't know how to identify consecutive sides, then it's going to be pretty difficult to understand what a kite is. Just as the previous page, I can't scroll up and down and save what's on the board. So I'm going to keep this diagram projected on the board. We're going to answer parts A, B, and C. So just make sure that as I do work, that you are writing it in the appropriate space. So, try to make it a little bit bigger so you can see it. Alright, so we're given this quadrilateral, K-I-T-E, and as of now, just based off of the diagram, and the diagram alone, all we can say is that this is just a quadrilateral, because there's nothing marked. However, they give us some information about it. It says, given the quadrilateral K-I-T-E with segment K-I congruent to segment K-E. So I know that this segment's congruent to that segment. It also tells us that segment I-T is congruent to segment E-T. Anything that I write on the board is probably a good idea for you to go ahead and write on your paper or in your textbook as well. So now, after reading this given information and marking my diagram, I now know that this quadrilateral is a kite by definition. If you were ever asked on a quiz or on a test or homework to prove that a quadrilateral is a kite, you need to go back to the definition. So you would need to show that that 4-sided polygon has, by definition, exactly 2 distinct pairs of congruent consecutive sides. You have to go back to the definition and prove this. We're going to learn a lot of different properties. We're going to see how their diagonals interact. We're going to see how opposite angles and opposite sides and things like that. But if you're trying to prove that a quadrilateral is a kite, you have to go back to the definition. You can't just prove some of its properties. That's like saying you have you have an animal and you're proving that it's a dog and you're like, oh, it's got 4 legs. Well, yeah, that's a characteristic of a dog, but that doesn't prove that it is. So you can't just prove characteristics or properties about these quadrilaterals. You can go back to the definition and show that that is true. Sweet. Okay, so part A reads, one of the diagonals divides the kite into 2 congruent triangles. Every single quadrilateral has 2 diagonals, and they're telling you that in a kite, if you know you have a kite, one of those divides the kite into 2 congruent triangles. I want you to identify which one of the diagonals does that, draw it in, write a congruency statement for the triangles, like triangle blah 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 is congruent to triangle blah blah blah, and tell me how you know that.